guys, welcome back to In Case of Econ Struggles. Welcome to another Causal Inference struggle. Today we're talking about balance tests. We're talking about how to test for selection on observables. We're also going to talk about good versus bad control. So timestamps are below if you would like to jump around, but let's go ahead and get started with good versus bad controls in a regression. The problem that we're facing with good and bad controls is that we're trying to estimate some relationship between x and y, which I've indicated here is +2. And we've got some other bunch of variables or controls or confounders w. So in this case, w is affecting both x and y. It's got a positive relationship with both of those, so we're going to expect some upward bias if we don't have any controls in our estimate of the relationship between x and y. You can see that here, even though that the true effect that we know is +2. If we don't control for w, then we're going to get this bias because x is going up because w is going up, and w also affects y. So the solution in this case is to control for w, because if I hold w constant, then the only change in x affecting y is that x is going up, which causes y to go up by 2. And now we've estimated the true relationship between x and y. I want to contrast this by a very similar looking scenario, but a scenario that's actually different. So here, notice that x affects y directly with +2, but x also affects y indirectly through w. So the true effect of x on y is actually 4, because it's this direct channel, which is +2. And then if x goes up, then w increases by 1. And if w increases by 1, then w increases by 2. So the total effect of x on y is 4. But if we were to try and hold w constant, if we hold this guy constant, we're only going to get the direct effect between x and y, which is +2. But that's not actually the true effect of x on y, because the true effect of x on y totally through direct and indirect channels is 4. So the key takeaway from this is you don't want to control for things that are causally downstream of x between x and y. So in the first example, w was a confounder, and in the second example, w was downstream or causally determined by x. So in scenario 1, you definitely want to control for w, that's a confounder. But in situation 2, in scenario 2, you don't want to control for w because that is a causally determined variable from x. This is something that can be kind of confusing when you're trying to think about your regression model and selection on observables, so I just wanted to cover it, but now let's go ahead and move on to this balance test. So here's the situation with the balance test. What you're trying to show is that your treatment group and your control group are comparable amongst unobservables. Because those are unobservables, you don't observe them, which means you can't actually show that they're comparable, that those two groups, the treatment group and the control group, are comparable amongst unobservables. So the best thing you can do is you can try and show that they're similar on observables. So what you can do is you can take a couple of common characteristics such as gender, age, income, race, those sorts of observable characteristics, and you do averages over the control and the treatment group. You compare those averages and you see if they're the same. So for example, let's say you've got male and age, and the average of that male indicator variable in your treatment is 0.55, so that would say that 55% of your treatment is male. The control is 0.54. You can do a t-test on those two numbers and see that the p-value is 0.568. Notice this is not significant, which is good, which means that at least for the characteristic of gender, your treatment and your control group are not statistically different from each other. But if we look at age, if your treatment group has an average age of 45 and your control group has an average age of 89, those are very different. You don't really even need this p-value to tell you that those are so significantly different from each other. So what this would tell you is you might worry that your control group is much older than your treatment group. So the results of this comparison are not going to be truly due to treatment. They might be due to the fact that your control group is just generally older. But this balance test is something you'll see in a lot of papers. It looks something just like this, where you have a table and you'll see your observable characteristics down the side. And you'll have your treatment and your control group as different columns. You'll see the averages, you'll see the p-values. The paper would generally talk about if any of those are significant, why it is or is not hurtful to their interpretations, to their findings, and so forth. But hopefully this just gives you a little bit more on selection on observables and the balance test specifically. If this was helpful, make sure to like and subscribe, and we will see you next time for another case of Econ Struggles.